Module 2, Topic 2, Lesson 1. We are getting into proofs, the wonderful world of proofs. Let's start with the warm-up. Determine each unknown measure. So as you can see, numbers 1, 2, and 3 are all linear pairs. So we could just subtract each known angle from 180 to get the unknown angle. So for the first one, 180 minus 97 is 83. 180 minus 79 is 101, and 180 minus 156 is 24. All right, here are your learning goals. Take a minute to pause the video and read. Key terms. These in particular are going to be properties of equality, and we'll be getting into those momentarily, but they're super duper important. They can be in proofs. Getting started. Okay, so we are going to basically take a look at these angles to the left. And we're going to be talking about vertical angles, proving that these are making vertical angles. So if we consider that these two are lines, okay, what is the sum of AEC and CEB? So we have AEC right here. We have CEB right here. And as you can see, they make a line. So they have a sum of 180. How do we know that these pairs of angles are supplementary? Well, that's because their sum is 180, and that's literally the definition of supplementary. How do you know that the measure of AEC and CEB together add up to the measure of AEB? Well, that's because we know, again, these are adding up to 180, okay? And we know that angle AEB is a line, and lines have a angle measure of 180. How do you know that your reasoning to question 3 is true? Well, if they both equal 180, so if this equals 180 and if this equals 180, then they must equal each other. So that must mean that this equals that, since we know that they both equal 180, which proves that this would be true. Okay. All right, so don't forget, a postulate is a statement that's accepted without proof. And here are 3 postulates: angle addition, linear pair postulate, and segment addition postulate. And you can see here, this is their explanation. Properties of real numbers in geometry. Okay. All right, so many properties of real numbers can be applied in geometry. These properties are important when making conjectures and proving new theorems. So the addition property of equality, here's an example. So if you just add to both sides, then if you have an equation, if you add to both sides, then it doesn't change the value of the equation. And then here, same thing with the subtraction property of equality. Okay, here, this is the reflexive property, so something equals itself. Here we have the substitution property, where basically if we know that 2 things are equal, then we can substitute them. Sorry, allergies. And then lastly, we have the transitive property. If x equals y and y equals z, then x equals z. So that was the answer to number 1. I just put them next to where they go. All right, down here we have a worked example of the addition property of equality. So the addition, actually let me use a highlighter, addition property of equality below. And as you can see here, we can apply it to angles. So we can just say, okay, well, if we know that angle 1 and angle 3 are equal, then we could add 2 to both sides, as we see here. And we know that's true because 1 plus 2 is a linear pair, 2 plus 3 is a linear pair. And we can also apply that here to segment measures and then distances using the same segment. All right, down here, consider each diagram and write a statement that applies. So the subtraction property of equality, and we see that here, if angle AEC is congruent to angle BED, so BED. And if we were to subtract BEC, so this angle right here from both sides, then we would be able to determine that, okay, we would be able to determine that this angle and this angle are congruent by using the subtraction property of equality. The reflexive property, pretty easy to see. Angle A is congruent to itself. Okay, the substitution property, so if we have the measure of angle A is 90 degrees and the measure of angle B is 90 degrees, then we can see that they equal, we can substitute. So we could say, okay, well, I know that's 90, I know that equals 90, so I can just substitute that right there, and A equals B. And then the transitive property, if angle A is congruent to angle B, like that, if angle B is congruent to angle C, then we can assume that A and C are also congruent. All right, subtraction property of equality applied to these segment measures. So if AB is congruent to CD, or equal, sorry, then if we add BC to both, so if we do AB plus BC, that should be equal to BC plus CD using the subtraction property of equality. Why did I do addition? We don't know. Let me fix that. Okay, hold on. Okay, let me fix all of that up. All right, so if AC okay, so if AC is congruent to BD, okay, sorry about that. So BD, here we go. All right, then AC minus BC, and we'll call this overlap BC, should equal BD minus BC. So again, AC, if you take away BC, that should equal BD take away BC. And then that should leave you with AB is congruent to CD. Oops, equal, keep saying congruent. Right, because if we take away BC from AC, then we're left with AB. Again, if we take away, so if this is AC, and then we take away BC, we'll just be left with AB. Reflexive properties, CD is congruent to itself, equal to itself. And the substitution property, if CD is 8 inches and EF is 8 inches, then they are equal to each other. All right, transitive property, again, if MN is congruent to WX, and if WX is congruent to RT, then we can assume that MN is congruent to RT.